Welcome to Module 14. In this module, we'll discuss XSS, or cross-site scripting attacks. An XSS vulnerability occurs when users supply data, which is transferred to a web application through GET or POST methods, is not adequately filtered, allowing for an attacker to inject an external HTML code into the generated page. The HTML may contain embedded JavaScript, which is executed in a victim's web browser. Data, such as session ID cookies, could be intercepted this way. A hacker may also gain access to a victim's computer. The so-called exploit packs are toolkits facilitating the exploitation of browser vulnerabilities. Once a potential victim opens an infected website using a vulnerable browser, the exploit pack installs malware such as Trojans or viruses on the system. XSS attacks are usually divided into two subgroups. Reflected XSS attacks take place when an exploitation string has been sent by a victim's computer through GET or POST whenever they visit a vulnerable page. For example, if the vulnerability occurs in variables passed through the GET method, the victim has to be persuaded to visit the specially crafted website for the attack to succeed. The second XSS vulnerability class is stored XSS. The attack occurs when an attacker is able to save malicious code to a server, for example in a database or a file, which means that a victim doesn't have to be lured to a specially crafted page and can instead be targeted while browsing a normal service, for example while reading website comments or a guest book. Let's now see an example of the reflected XSS flaw. You can see here a simple script which simulates browser actions. Search engines embedded in web applications will very often redisplay the string supplied by users. The same mechanism is employed here. The content of the form is sent via the GET method, and the search result is displayed. Let's see how this script works in practice. As you can see, the string has been displayed. We might notice that user-provided data is not filtered, which means that an attacker has full control over the shape of HTML code, which will be reflected and may use this to inject a JavaScript. All it takes now to execute the code embedded in the link is to send the URL to a victim and persuade him or her to click. Let's now move to another type of XSS vulnerability, stored XSS. You can see here a simple guestbook script. Comments are passed to script via POST and then saved in a database. All comments will be next retrieved from the database and displayed. As you can see, since the script doesn't validate input either, we can expect that it will also be vulnerable to HTML code injection. Since the malicious code will be saved in a database, this would be an instance of stored XSS attack. You can also see here a simple control panel. If valid user credentials are submitted and checked in the database, and the user is logged in, the site will display an appropriate message. Imagine that the browser represents a guestbook administrator. We've logged in successfully. Imagine that the other browser represents a hacker trying to exploit the XSS vulnerability. For the purposes of this presentation, we've created a script which creates a script tag and sets the address of a sniffer, which is a type of software that can capture user-supplied data passed through the GET method. In this case, the sent data is the content of the cookie variable. Finally, the tag is added to the DOM tree. This provokes an attempt to load the script and the sending of the GET request, which will contain cookies. The sniffer PHP file logs all referred parameters to a sniffer log file. The file could be stored in the service which has been taken over by an attacker. In this way, the attacker could obtain access to data stolen from the vulnerable website. In our case, this data is a PHP session ID. Let's copy the script and try to add it to the guest book. As we can see, new elements have been added to the page. The site source code now contains our script. In this case, the code has been immediately executed on the attacker's side. And so the first entry in the sniffer log contains the attacker's session ID. Imagine that a logged-in administrator visits the guestbook page. As you can probably guess, the script which sends data to the sniffer has also been executed on the admin's side. The sniffer log file holds admin session ID. Let's try to exploit this. Using the Live HTTP Headers add-on, modify the request sent to the guestbook by setting the stolen admin session ID. As we can see, the attacker has gained control over the administrator session. You probably realize by now how serious XSS attacks could be. How can they be prevented though? The simplest way to do it is to filter all input. User-provided data should be treated with caution, as it could contain malicious elements. If it is not necessary for the users to be able to add HTML tags, we could employ the HTML special chars function. The function converts all special characters used by an HTML interpreter, such as the opening and closing tags or quotes in HTML entities. The entities are displayed normally, but are not rendered by an HTML interpreter. Let's see if setting this function helps. Let's try to exploit the reflected XSS vulnerability once more. As you can see, this time the code has been displayed, which suggests it hasn't been executed. The code of the site contains the AND-LT and GT characters. They are displayed, but not used by the HTML interpreter to identify tags. If you want to allow users to insert HTML tags in your application, using the BB code mechanisms might be a good idea. BB code encloses tags in square brackets and then translates them into individual HTML tags. That's all in this module. See you in the next part of the course.